Hey, everybody. Thank you for joining our requirements management webinar here. I'm joined with my colleagues that are going to present today and walk through all of the requirements management content. My name is Tristan Eggenberger. I'm the business developer for our Detroit office. And I'm going to give a short introduction, just a quick little cover of who we are as INVENSITY before we dive right into the requirements management topic and I hand it over. I promise I'll be brief. I just want to elaborate on a little bit of our experience and our knowledge and the things that we're working on currently. Just a couple of kind of say guidelines or housekeeping. We really encourage all questions that you have throughout this as we're going through the content. So please don't hesitate to comment some questions. We'll make sure that we're collecting them. We will hold answering the questions until the end. So we'll go through the content. But if you have a specific question on a specific slide or topic, we will for sure go back and we can address that question. So without further ado, we get a quick look into INVENSITY. So who are we? Where are we coming from? We are an engineering technology consulting company, and we focus primarily on embedded systems. We do a lot of product development and process optimization around embedded system development. And we're a global company, as you can see in the middle left square. We have 8 international offices. We're in Germany, we're in the Philippines, in Spain, and here in North America in Detroit. We're working globally in 8 industries. Of course, Detroit being Detroit, we're quite focused on automotive here in this office location. Maybe I should mention too, my colleagues that are joining me as well are also from the Detroit office as well. And we offer 9 consulting services primarily. We group these into our what we call centers of excellence. So that's what you can see on the middle right square with data systems, software engineering, analytics and sensorics, and the rest that are listed there. We have around 250 employees. We've done thousands of projects with hundreds of customers, and we have used all of this experience and knowledge that we've gained to collect best practices and lessons learned so that we can bring this experience and support our clients with the engineering development challenges that they're facing to provide really engineering excellence for them. And our goal is ultimately to enable our clients so that they understand not only what we're doing to support them, but also why we're doing it and how to do it. Because that, for us, is a really successful project when we can walk away at the end of it and feel that the client's team is enabled and developed in a way that they will be able to handle such a challenge in the future. So when we look into these consulting services to dive a little deeper, we offer 3 main areas of support. So we offer management consulting. This is when we look at like strategy and analysis. Organizational change is a great example for this. There's a certain competence that's needed to provide organizational change for an engineering organization, for example. They're developing a brake system. Then the people who are running the organizational change approach and advice giving need to really understand how that product is developed and the roles and responsibilities and qualifications that are associated with that. Then we look in the middle, we have technology solutions. So this is really expertise in management. So things like on the right side, you see method and standard expertise. ISO 26262 is an extremely common one, I'm sure pretty much everyone is familiar with. So we support interpreting that and applying that to your product and your product development so that it can be streamlined and effective. And then towards the bottom, we see engineering solutions. And this is more about really defined roles and providing expertise and qualification there. Not to be confused with a staffing agency or a resource agency. We don't want to mislead anyone. We always start every project with really defining a solution, a plan, a schedule, and an approach, and then we do the implementation. So if you're curious to learn more about us and how we approach these projects, we are always willing to have a conversation. We'll walk you through how we would approach your challenge before we would ever bill or start a project. And only upon your agreement that this makes sense would we actually go that extra step and really finalize it and kick off an official project. So just wanted to put that out there in case anyone is curious to talk to us after this. We'd be more than happy to. And on the next slide, just to give everyone a little idea of some of the clients we've worked with, here's a small extract in the different industries that we are in. I'm sure there's many familiar company names that you all recognize. So with that, I promised to be brief, and hopefully I kept my end of the bargain. I want to get into the requirements management. That's why everybody's here. Just wanted to give a little bit of background to where we're coming from. So I hand it over to my colleagues, Max and Enoch, and I'll let them introduce themselves and tell you a little bit about what you can expect today.
So, hi everyone. My name is Max Franklin. I am a consultant in our Detroit office, as Tristan mentioned. I have over 10 years experience really in new product development, advanced product development, kind of with a systems engineering focus. And that's what I've done in my time at INVENSITY, helping clients in a variety of markets, aerospace, automotive, commercial vehicle, getting to successful product development, and that's what we want. Great products and a great time getting there. So yeah, that's me, and we'll let Enoch introduce himself, and then we'll get into it.
Hi everyone, this is Enoch Lee. I'm also a consultant at the INVENSITY in the Detroit office. My background is in mechanical and aerospace engineering, but I've been working on systems engineering projects primarily with tier 1 suppliers in the Detroit office. Look forward to sharing some of our experiences with you with regards to requirements management.
Great. So you can see on the slide is kind of our agenda for today. And so we talked about INVENSITY, but really what we're doing today is just sharing our insights from our experience and research, and sharing some things that we think will be helpful for everyone here, and pique some interest and see if there's opportunity for you all to go back and make some difference within your organizations. So we'll do an overview kind of what are requirements and requirements management. What does that really mean for us? And talk about some of the challenges and opportunities that come from that. Then Enoch's gonna then really talk about what kind of an optimized requirements management process execution looks like from our perspective, and kind of how to affect those challenges and opportunities we'll talk about. And we'll leave plenty of time for questions and answers for everyone that's interested. So we'll get right into it. So really, what are requirements? And how are they used, and really why are we talking about them today? So when we talk about requirements in terms of product development, we're talking about the specific details that describe either the properties, the qualities, the functions that the product to be developed really need to have. And we'll use different terms. The product can be an end product that's used by a consumer or the end user. But if you're a tier 2 supplier, then your system or component really is your product. So we'll jump around between those terms today. But whatever you're developing, that is what we can have requirements for. And so, yes, ISO 9000 talks about a requirement or expectation. Is something that is determined usually and is presupposed or mandatory for the item. And when we talk about requirements, that's really what we mean. We're talking about the things that our product has to do. And some of those can stem from design decisions, marketing decisions, and so on. But if we take the case of our graphic here and we look at a phone, yes, there are key functions that it has to do. Turn on, connect to a network, make a call. Some people actually still make phone calls. But then there are other things like weight, size, screen size, power consumption, that these all stem from design decisions, marketing activities, evaluation of what the user needs. But then somebody, in general, maybe a chief engineer, a product leader, makes the decision that this is what must be executed during this development. And that's when something becomes a requirement. And so what does that really look like as we keep going through systems engineering? So hopefully many of you are familiar with kind of the V model, as we call it, of systems engineering, where you kind of do your development work kind of from top to bottom on the left side, and then you go kind of up the right side of the V in terms of verifying and validating that what you designed for actually does what it was intended to. And so we really think about requirements as the foundation for a lot of these activities. Certainly, the implementation is incredibly important. Writing the code itself, doing PCB or mechanical design, bringing that that strong design creativity, industry knowledge that all of you have, and the engineers and developers at your respective organizations have. But we want to make sure that everyone is implementing the right thing. So if we look at how the left side of this V is defined, we're talking about these requirements. And by the way, this can be at each level. We can talk about the high level product requirements, we can talk about system requirements or component requirements. But there's definition of the requirements, some of which maybe we don't have an influence over, given to us by a customer, and some of which we go and elicit and define ourselves. And then that goes down to how we do our system design and defining key features and functions, and then getting into the technical design and being creative and making sure that the how meets the what that is needed by the requirements. And then that gets filtered down into components, which may come from suppliers or may come internally, and so on. And crucially, and Enoch will talk a little bit about this later, through successful requirements management, we're very integrated with what may be called test management. We're making sure that at each level of product integration, and through qualification testing and so on, that we're actually testing the right things at the right levels. We're not trying to show too much at a component or software or model in the loop level, and we're not waiting too long until we're in a vehicle to be testing these specific things. So hopefully this resonates and gives a little kind of insight to how requirements play in greater product development. And it still doesn't necessarily justify why we're talking about this today. So hopefully this will. And so the research shows that over 52% of very unsuccessful, basically killed projects result from inadequate requirements management. And so what that means is specifically identified that the requirements that were being designed against or executed were incomplete or inaccurate. A lot of it is lack of involvement of stakeholders. We'll talk about that a little bit more. But the best way to have input from all of your stakeholders is to have the requirements and acceptance that we need from all of them. Unrealistic expectations. And what that means is that effectively requirements were cascaded that should not have been a part of the project, or that resources did not meet that. Requirements changing, that's fine. Requirements are allowed to change, but when you're not tracking them and you don't have visibility to how that affects everything, that can be a requirement, and then, or sorry, a major issue. And no longer required, we'll talk about in a second. But this is pretty stark. Right? Half of the reasons that projects fail can be completely eliminated by implementing a decent requirements management system and some strategy around that. So that's a huge opportunity, and hopefully that resonates, and that's why you're listening today. So, but really, what can we do about it? So, and if anyone was at our panel a couple of weeks ago, you heard Tristan mention the project management pyramid, and this has been discussed in our project management webinar as well. Really, these three main drivers of a project: time, finite costs and resources, adjustable, but there are consequences to all of that, and then quality. Right? And if we can have our ideal product development, we want the highest quality possible, with the lowest core cost, the fewest people working on it, and as quick as possible. So normally you have to balance, sacrifice one to gain benefit from both. And we think that requirements management is really this activity that can affect all of these. So if you think about misidentified customer wants and needs, which either cause insufficient quality or too high a quality and then too high a cost for the market, that is your product level requirements. And if we don't have strong enough or complete specification of product and system requirements, then we won't meet what the customer needs. Or, as unfortunately most of you have probably seen, requires a ton of re-engineering, revalidation when we get a very unexpected test result, or we're years into a program and see that something is not doing what we expect it to do. On the flip side, something that's over-specified means that we're driving up costs and driving up time and driving up resources when we didn't need to. And those are all people that could have been working on other projects or future activities. And we could have delivered a product to the market sooner. So we'll see a little bit more of that in this slide, and don't need to repeat myself too much, but certainly the farther we get in a development cycle, the more difficult it is to make changes. And outside of over-the-air updates and software reflashes and other things, which still require time and effort and have a cost to it, if you're trying to make major design changes once you're into prototyping or production phases, it's very, very difficult and really costly. And you can see those costs on the right. We're talking about a couple days of engineering time to fix something during concept phase, or A sample, B sample, or early stages. And once you get into DV and PV and production, we're talking about a singular fault, what the costs associated with that are. So the whole idea is that by strong understanding and execution of requirements, we can make sure that we are being most active and fixing things as they're needed as early in the project as possible. I'll go a little quicker through this. Just some of the challenges and opportunities, and if any of these resonate, feel free to leave a comment in the chat box or ask a question about any of this. But sort of when we talk about requirements management as a template, there's plenty of engineers and developers who are very creative and can come up with some great stuff. But if there's deadlines and we want to be efficient, it's really hard to just kind of start from scratch, like writing code to try to execute something. So understanding requirements, breaking things down into specific features, being able to define a software architecture that outlines how we do development. These are all kind of opportunities available to meet that challenge. And then we've talked plenty about is that we want to, eliminate faults as much as we can and push them as early in the project as we can. And the more requirements we have that are cascaded and met, then the less, the less faults we're going to have, especially down the road. Yeah, specifically, so we want high quality and making sure that we're executing the items that are going to bring that quality. We can do that by focusing on executing our requirements that exist. And prioritization is a huge benefit. And really what we're talking about here is you have an early stage build, an A sample needed, proof of concept testing, maybe even a big project or gate review, where we need to make sure that the key features are really working to figure out if we're going to continue on this project. So prioritizing, hey, this is all we need to work on right now to execute our 3 key features. And all this other stuff that's for secondary features can happen during our next phase of development, and making sure that our team isn't spending unnecessary time too early in the project on things that are not going to affect, say, the most important features of our product or system. Test and acceptance, we talked about kind of on the V model. How do we know that we're writing tests the right way? That existing tests, carryover tests from previous programs, specific test specifications from the customer, are those actually demonstrating what we need to be demonstrated? Or are we going to wait until there's a fluke situation in the vehicle, or on customer vehicle testing, interaction with another system, and all of a sudden there's an issue? So making sure that we can test all these things as we go along. And then argumentation, and making sure everyone's on the same page. So we'll dive into that a little bit more. And so what you see in the middle of this slide is kind of a look at stakeholders and who are all the stakeholders on a project. And by the way, this is a great activity, whether or not you specifically call it part of requirements management. But the idea is that every system and product is going to be a little bit different, but there are kind of these key players involved that we may not think about every day. And even if we have a contract and development package from a customer, that doesn't mean that everything we need to think about is in there. Are there industry or regulatory standards that need to be considered? Is there something from Department of Transportation or NHTSA, Department of Energy? Are we selling into multiple markets? Is there something different in Southeast Asia than in Western Europe than in North America? And this can affect, so understanding all this is part of kind of what we call requirements elicitation, one of the first activities in requirements management. And it's not just making sure we have all the requirements we need, but it's making sure that all our key players are involved from the beginning. How are they going to be involved? Are they providing requirements? Are they agreeing to or accepting requirements? Are they simply responsible for the execution or kind of design specification that comes from that requirements? So I've been a part of some really cool kind of stakeholder identification activities and establishing the roles that everybody has to play and that they want to play. And that's kind of a really cool way to get everybody involved. And then through your requirements management system, you can make sure that all those voices are heard and considered throughout the entire course of the project. Costs, I think we've talked about enough already, and acceptance we just touched on. So I think one last thing before we kind of move to what a system will look like is, not that different from the graph we saw earlier. The number of requirements we have to deal with only grows as the project goes on. And if you think about, let's just say we're working with an OEM, we're working on an entire vehicle. As we develop those vehicle requirements, then each of those gets cascaded down to the systems that have to execute it. And each system has to write multiple requirements of their own to meet those higher level requirements. And the same now for each component or subsystem and down to hardware, software, and the different suppliers. And so this can get really unruly. If you've found a way to manage 20,000 requirements using static tools or a spreadsheet or a filing cabinet, great. Please reach out to me afterwards because I'd love to hear how you did it. But this is a nice visual representation of why it's so important to have some kind of tool that can be used for your requirements and really how to how to track everything over time and make sure that we're working on what we're supposed to. And just a key point here is that if you imagine if we make an error, whether we have the wrong value or we miss something, we misinterpreted something, just like we talk about, if we catch it early on, if we catch it before gate one, before it's been propagated, great. If there's an error and now it's affecting thousands of requirements, that is much more difficult to clean up. Similarly, if we've been really smart, if we have some key insight, if we know something that is really going to lead to a successful product development, then we want that shared with as many different players as possible. And so if we do that right from the beginning, you can see that that's also going to affect thousands of requirements down the line. So that's really the huge opportunity and something we want to focus on. So now I'll hand it off to Enoch, who will really talk about, to get this stuff right, what we think a system should look like.
Yep. Thanks, Max. So Max talked about like how the system the set of requirements can explode exponentially over as the product matures. And I'm going to talk about like some of the best practices we use to try to manage that early on. And obviously, if we can set a good foundation for requirements management, it's going to be a lot easier to manage the entire system as it mature down the line. And first of all, like a requirements management strategy should be developed, and preferably at the start of the program and maintained throughout. The requirement management strategy is essentially a kind of a pseudo table of contents of requirements management. to me, requirements management is really a technical communication between technical teams, exchanging information, how to develop things, and seek agreement between teams who are oftentimes from a very different background, from a technical background or other backgrounds. And what a requirements management strategy does is really try to define who are the stakeholders for the requirements. So for example, if I in product development, I encounter a software issue, do I go to software team A or software team B, or do I find the source of requirements from different teams, for example, and really defining who is developing and reviewing these requirements in one page or in one document. And also what RMS does is defining what are the work products being produced. It could be systems requirements, it could be review records, traceability of records, which are all very relevant to maintain a good requirement management solution. And also RMS also define where are these being stored. Organizations could be using a dedicated requirements management tools such as Doors NextGen, or JAMA. And defining this in one document is really important for people who are joining into the project, or as development projects could last for years, and for new people to know where things are. And finally, the RMS really define how are the requirements being maintained in the system. It defines the requirement lifecycle, which I'll go into in more detail later. It also defines the link structure of how we're managing the requirements. Oftentimes we see that there is a lack of clarity in terms of linking and requirements in our client's project, where things can link to very different wrong areas and creates traceability issues, and we're not able to see if a requirement is verified or not without going through the subject matter experts and understanding what's done under the hood. And the RMS really is there to give clarity at a high level as to how we're approaching a requirements management solution. So moving on, okay. So at the start of the program, really want to get a good start. We don't want to migrate whatever product you had before, the set of requirements that define the product blindly into the new product. What we found is in some of my clients who did that, they run into issues where down the line, maybe years in development, they realize that, hey, this requirement actually makes sense for the new product. And that led to a lot of re-engineering work, re-investigating work on a specific requirement. And especially when projects can last in multiple years, teams can change, engineers can change. That information might be lost in that change, or being reassigned to a different team. So you don't want to have, for the sake of convenience at the start, to have transfer those public requirements. It could make sense for a new product into the same product, and leave the issue to deal with the issue later on in the development cycle. So at the start of the program, we really want to understand the client needs. For tier one suppliers, it might come from a customer requirement specification. But that should be used as obviously when you satisfy those requirements, but also we want to look into what are the other solutions that as a tier one supplier we have developed and which are relevant directly to the new product, and use that as a basis to define the best starting point. And this will allow us to minimize the number of re-engineering down the road. And as Max mentioned, if the issue is found in requirements, for example, later down in development process, it will be a lot more costly to fix that issue than figuring out when we're building a good starting point, a good foundation for the set of requirements going into the new product. So some of the things that we found that's very useful as we develop the requirements management solution is really trying to categorize product features and attributes early on. And this will allow us to better understand the product and define requirement type and classify them. And when I say attributes, this can vary between organizations, but we can decompose into intangible, tangible attributes that Max talked about in terms of mass, size, that kind of thing. And features, we can decompose that into communication, perception, actuation, etc. And this, a high-level categorization will allow us to really prioritize requirements and understand the full picture as a requirements engineer or as a chief engineer or whoever is interested in knowing the full picture of where the product development is. So another thing that we want to define early in the development process, as I mentioned before, is the requirements lifecycle model, which can be defined in the RMS. This should be defined and tailored to a specific project, organization, and context. What this is really is a way for us to track where the requirement is in its development and implementation. And we like to use three different status tracks. One is from the perspective of whoever is writing the requirement, usually a systems engineer or requirements engineer. The other one is requirement receiver. It could be the subject matter experts that the requirement is allocated to. And this really is the two sides, two major sides of how a requirement should be: the one who's writing it, the one who's accepting it, and given its his or her comments or technical expertise as to how if a requirement is feasible or not. And finally, we have a third perspective, which is coming from a more quality engineering perspective, from a perspective of whether the requirements management process is implemented correctly for this project. For example, we found that a lot of our organizations always have, the bigger organizations definitely have the quality engineering department, and this is where they come into play and to give their feedback on not the technical details of requirements, but really on the quality, the procedure compliance of certain requirements. So this will allow us to track how requirements mature. If it's approved, then this will also allow us, if using the right tools like Doors or JAMA, we're able to create these dashboards, which are very powerful tools for decision making, to understand like where the projects are, where the project is, how many requirements are covered in terms of if it's traced to a test case or decomposed further, which I'll go into a little bit more detail later on. So Max talked about requirements elicitation, and how do we cascade that into a proper requirements management solution? What I'm trying to say here is more of a high-level view of how that can cascade into a requirements management solution, which kind of trace the V model. So after requirements elicitation, we have collection of stakeholder requirements from the customer. It could be OEM, or it could be individual consumer if you're selling directly to consumer. And after that, you really want to decompose that into system specification. Essentially, it is how the customer requirements can be implemented in the organization's view. Oftentimes, we saw that our clients sometimes would copy directly from the customer requirement to system specification without much analysis, and that is not, I would say, it's not advised because it skips through the analysis process, which is very important considering all the development team, the capabilities they have, which is skipped over if you copy directly, and it might lead to a situation where in a few months down the line or a year, you realize that, hey, this customer requirement actually doesn't make sense. Like if you're so far down the line and you come back to your customer and say, hey, we can't do this. It might lead to, well, obviously it will lead to a fairly awkward situation. Like, why? The first question might come up is, why didn't you catch this? This seems obvious to you if you did the analysis. So for system specification, you really want to take the internal standards or other regulations, especially for automotive or obvious customer as input, and really define the systems requirement that is tailored to not just the customer specification, but also what are your internal procedures or internal technical capabilities. And after that, we can further decompose that into subsystems, for example. And this really doesn't really, we're not saying these are all the levels here, but these are the high level levels that we can decompose into. And from subsystem, we go into components, for example, and it could go further down if the organization, if the engineering team is set up in that way. And really, we found that a predefined relationship diagram in the form of link structure, or it could be a rule that's set on a requirements management tool like JAMA, really solidifies this process. What it does is it prevents you, it's set up to prevent you from linking, for example, subsystem requirement to directly to customer requirement, for example. In certain circumstances, we do see that as something that it's being done and there is a valid reason for it. But ideally, it shouldn't be, because that way, then you have requirements linking from anywhere to everywhere it could be, and that leads to a nightmare scenario to manage that and how to ensure that traceability is established. So I'm going to go through this very quickly. When we're decomposing requirements, you really want to, it's okay to have one high level requirement to decompose it into one lower requirement. Ideally, we could decompose one to multiple requirements downstream. And we also saw that multiple requirements going into one sub-requirement in the lower level. But what we want to see here, and especially if everything is in a central database requirements management tool, we can quickly identify like orphans requirements. Like orphan requirements in subsystem, we don't really know where that is. I mean, it could be something that's known to the design engineer early on, but then for people who are entering the project, or if as it develops in time, we don't necessarily know where it comes from. So what we're saying here is we need to have a source for all requirements to find in a requirements management system. If there exists a gap, then that should be a prioritized task to make sure that requirement has a source and make sure that's relevant for any products that's in development. So requirements management is not complete without the other side, even though that's not requirements, that's more of a testing perspective. But how do we know without that traceability that a requirement can be verified by certain activities? It could be a test, it could be an inspection, it could be a demonstration, or it could be just a simulation or analysis. So we really also want to capture the traceability in the link structure, for example, if we're using a requirements management tool. And for every requirement should be verified either by inspection, demonstration, and analysis, or test. And it is possible to have for a requirement to be verified by multiple tests or multiple methods. And one test can also verify multiple requirements. Not ideal, but it's possible. And tests that are done without any related requirements, but should be checked whether they're necessary. And we often found that sometimes our clients have their internal test specification that they run for every product, which makes sense. But then they're run sometimes without any traceability to customer requirements. So are these tests relevant? Usually yes, but it leads to that question. So establishing that traceability early on, you really answer that, okay, here are some internal tests that we run for every product we do. And now we know that these tests satisfy certain requirements, verify certain requirements. Then we know hey, we can have more confidence in the traceability established by the requirements management solution. So finally, for each individual requirements or set of requirements, we have a set of 6 quality when writing and reviewing these requirements. A requirement should be relevant to the situation, it should be unambiguous, should be interpreted in one way. Again, requirements management fundamentally is about communication between team members, and being unambiguous is very important, especially with teams with different backgrounds. It should be verifiable, and verifiable is not necessarily just tests. It could be inspection, demonstration, analysis, and test, and it's traceable. And these are the qualities that can be judgeable for every different individual requirement. And as set of requirements, we want to make sure that they, as I said, they're complete and consistent, and complete as in are these requirements, set of requirements, actually making sure that we are designing to a certain customer need. And we also want to be consistent, and it's just language, formatting, all that stuff, to make sure that this is something that we can give to a new employee, and he or she will be able to understand at a high level what we're trying to do, and consistency is key. So I think that ends my brief introduction or brief summary of how some of the things that we do in optimizing requirements management.
Thanks, Enoch. That was great. So now we, we'll open up the floor to questions. We'll give everyone a little time to jot down anything you have in the YouTube chat. And I think Tristan can fire questions at us as they appear.
Perfect. So we do have one question already, but firstly, thank you guys for going through all of that content. That was great, and I'm excited to have a bit of open discussion here and a nice Q&A. So let's look at the first question that came in. How would you address the requirements that don't make sense after an initial analysis?
Yeah, that's a good question. And that's why I kind of mentioned that in the requirements management solution, there should be a review record to make sure that at this point in time, after a certain analysis, we have certain things certain reasons why a requirements can be irrelevant at that time. And with that record, in the requirement solution, you can say you can put it as a requirement, but it's withdrawn for the time being for certain reasons. It's very important to have that record, because down the line, if say 1 year after initiation and you're in DB phase towards the end of it, that requirement suddenly becomes relevant to the situation now. Then you can come up and say, hey, we did this analysis before. This is why it was irrelevant at that time, but now this is the reason why we have that that's relevant now. Then it gives you a solid reason to flip that switch and say, hey, now this is relevant. And through, it's, again, requirements management is fundamentally communication. And if we have that traceability record, review record somewhere in the system maintained or in the requirements management tool itself, then you will have a basis to make your case. If it's not relevant before, but now relevant.
Perfect. Max, anything to add on to that, or feels like I was pretty comprehensive?
Yeah, no, it's a great answer. I think there's also potentially a more simple answer, which is the last slide that Enoch talked about. Sorry. Which is, maybe the requirement just doesn't make sense because there's an issue with it. So making sure that we evaluate this criteria and are able to right there just understand that we can write a requirement to have it make sense is maybe the first step before what Ian and I talked about too.
Absolutely. Thanks for the add-on. Thank you for the in-depth answer, both of you. Another question, what are the common challenges associated with implementing requirements management? And maybe if I can quickly add on to this question from my own perspective, also let's add a little caveat and say mostly we have requirements management approaches and strategies defined at some level, right? I mean, if we're developing products in a professional way, there's something existing. So maybe we can rephrase the question a little bit as what are the common challenges associated with implementing requirements management and or optimizing requirements management from an existing approach?
Yeah, great question. So I think one of the biggest challenges at a lot of organizations is just getting over the hurdle of really doing it and setting up a system. And it can be tough sometimes. You need it, as we saw from from a slide like this. If you're going to do requirements right, and you are a high level system or end product, you need a lot of people to be involved, and often, and especially in mature organizations, people teams can really be used to doing things a certain way, and in general, they've executed very well for a long time, working in a certain manner. So, what again in general, what we try to do is really when we talk about the stakeholders, identifying the key stakeholders, and catering, tailoring a system to work for them. We'll never go in with like a canned solution and say, hey, here you go. It has to make sense for everyone that's going to use it. Otherwise, the tool won't be used, the process won't be followed, and you can end up in a messier situation than you started with. So we've really seen some positive feedback from tailoring a solution specific to not even just the company or the team, but the project itself, the specific people involved, the needs of the project, who they're interacting with. We really see that as one of the challenges and kind of a way to address that. And if that wasn't the answer that was being looked for, feel free to respond in the chat.
And two, I think if I can sum up a little bit of what you said, Max, and what you talked about already too. I think there's three large topics that filter into this question, and one of them or two of them you mentioned, and one is organizational complexity, and that's been increasing. There's a increased need for specialized teams, which makes it necessary to grow the team size and have these different specialties. And every group tends to have, as Max was saying, their own goals, their own objectives, their own methodology and approach that they use to a certain extent. And we need to make sure we're doing stakeholder analysis and stakeholder interviews to account for all of that when we approach optimizing or defining requirements management methodology. But as well as organizational complexity, there's also just the massive scope of requirements management. I mean, it is not a small piece of product development. It is such a large methodology, and there's a lot of, we'll say, room for challenges to pop up. And the final point would be just the increasing complexity of products in today's world. I mean, it's just mandating that requirements management be taken more seriously as both the product complexity and expectations increase of the quality, as well as consumers have a ton of access to just go online and review products. So it's hard to release a product that is not meeting the public's expectations, and requirements management is a way you can really support and foster the ability of your organization to deliver. We have another question. What is INVENSITY's approach towards balancing certain clients' needs of requirements and their need to be agile? So how do we balance this, really focusing on requirements management, and then we'll say in a really realistic setting, sometimes we need to be quite agile and quite fast. So how can we balance those two things?
Fundamentally, I think Agile and requirements management solution, they're not mutually exclusive. And from an Agile perspective, you can think about like running through a V model in very short iterations and sprints, and making sure that the client voice of customer is or inter-team communication expectations are communicated in an Agile way. So really, and we also, by the way, we do have a few Agile project management experts in the team here, and we're going to experiment with how we can implement these requirement solution in an Agile way.
Yeah, and I think when we talk about feature prioritization and stuff like that, it works the same for Agile. If you have a specific development goal, if you're working on a specific sprint, the team members involved, and you have the idea of a timeline, then you set up the requirements that you need to execute on, whether that's review, analysis, cascading, decomposition, testing against them. It's actually really a nice way to break down what happens like during each sprint or campaign, and how to make sure that you can really quantify the results of that.
Awesome. Well, I think we are right at the edge of our time. So I'm sorry, there's a couple other questions, and thank you, Max. I was just about to ask you. We are happy to field these questions. If you just reach out to us for those that we weren't able to get to, I apologize. But as you can see, here's all of our contact information. So please feel invited to reach out to us and just ask us those questions, and we'll get back to you. But also please be invited if you have any other questions. We do quite a lot of requirements management, as you might be able to tell, but we also work in a lot of other areas, as we kind of gave a quick overview in the beginning. We'd love to meet with you, talk about engineering challenges and best practices, lessons learned, whatever might be interesting to you. We're in the business of helping other companies and other people wherever we can. So please feel invited to reach out to us. And big thank you for everyone joining us. We really appreciate your time. And we always love the chance to spread some of the experience and knowledge that we've been fortunate enough to gain through the many projects that we've done. So thank you to everybody. Thank you, Max. Thank you, Enoch. Really appreciate your time, and really appreciate everyone being here.
Yeah, same. Thanks for all the questions. Thanks for being here, and definitely reach out, follow up. We're happy to chat about this anytime.
Fantastic. All right. Have a great day, everybody. Thanks again.